All right, so the chapter 2 review sheet. Now, number 1, plug the 4 in for both a's, 4 squared minus 3 times 4. And like I said, before, you can just type that in if you want. You don't have to do the order of operations. If you type that in, you should get 4. If you were to try to do that out, you'd have to do, well, there's no parentheses for b. E for exponent next, so that'd be 16. And then you would multiply 16 minus 12 is 4. Now 2, put the 10 in. Like I said, if you just type that in exactly like you see it, you'll get the right answer. So that'd be fine to do that. If you do it out, it'd be multiply first, negative 30 plus 2, negative 28. And now 3, those are absolute value bars. Absolute value is always positive unless it's 0. So the absolute value of 4 is 4. That becomes 3 times 4. Well, negative 3 times 4, negative 12. Now 4, we have negative 4 times g. So negative 4 e parentheses t squared plus t plus 2h. So plus 2 slap parentheses around that 4t minus 3. Distribute the negative 4, negative 4t squared minus 4t. Distribute the 2 plus 8t minus 6. So we can put the t's together in the middle. Negative 4 plus 8 is 4. And that's it. Now 5 says f times g. So we just multiply those binomials. Got to use parentheses. So 3 times negative 1, really. So negative 3n times n squared plus 6n. Just be careful, that's double negative there. So plus 4n minus 8. Put the middle 2 together, 10n. This f minus g, so here's f, there's nothing in front of it, so I don't need parentheses because I don't have to distribute for this one. So minus g, but in order to subtract all of that g there, I got to use some parentheses. Distribute the minus. Double negative plus 5n. Now, we're only going to be able to combine the n's there. Leaving n plus 5n, that's 6n. I want the negative 3n cubed first. That 6 is positive, so I'll write plus. And I'll move that minus 3 to the end. Now, rearranging it like that isn't really necessary for full credit on the test for me. As long as you do it right, I'm happy. Sometimes on the multiple choice, though, you got to realize maybe they would have that n cubed first. Now 7, 5 times g, 5. Now I got to multiply all of g, so I need parentheses, plus 3 times f. Again, use parentheses. Make sure you multiply that whole thing by 3. Distribute the 5. Distribute the 3. So 3 times negative 3 minus 9x squared. Minus 9x. I'll put that negative 9x squared first. Not necessary on my tests for all the credit, but might as well do it. Now, negative 15 minus 9, negative 24x. And then we'll just drop that 10 down. Even, odd, or neither. So again, the test on a graph for even is if it's a mirror image down the y-axis. So if I fold that over the y-axis, I didn't do a great job there. So if I fold that over that green line, it will line up on itself. Even. Now on 9, the test for odd is you take your paper and you turn it upside down. And no, this doesn't go very well, but I'll try to turn this upside down for us here. If we take a look before I do that, start in the upper left corner, going down to the right, going through the origin. This never goes very well here. Oops. This drives me nuts. Almost there. It's a lot easier when you're using a pen and paper. There we go. Yep. So that is the same. Starts in the upper left, goes down to lower right. It's 100% the same after I rotate it 180 degrees upside down. Try to get back to where I was before. Almost there. There we go. There we go. So 9 is odd. Then, if I turn that upside down, the V is going to be upside down. So it's definitely not odd. If I try to fold it over the Y, it's definitely not going to line up on itself. That'd be right there, and then that won't line up. So that is an either. $11, show the function is even by substituting negative x. You just change x to negative x with parentheses. Negative x to the fourth, negative times negative positive, negative times negative positive. So that's the same as x to the fourth. Negative x squared, negative times negative, positive x squared. So the whole thing is exactly, what did I write? I'm sorry, guys. That's a 3. Okay. The whole thing is exactly the same after I realized I miscopied the 3 to a 4, but, you know, sorry about that. At least I caught it. Okay. So the whole thing is exactly the same. No negatives, escape those exponents to change any signs. The whole thing is the same, therefore it is even. And I showed it, that's all the work. Now let me write this one down correctly. Show this one's odd. Negative x times 5, negative 5x. That one's easy to go through. But the sign changes for negative x to the third power, negative x cubed. The first two powers, negative times negative positive. But then the third power switches that, leaves it as negative x cubed. So minus, that one I just copied down. Then we have, and you know, I'll get rid of these parentheses to make it less confusing for you. This right here is negative x cubed. So we got a double negative, which switches that to plus x cubed. 5 change signs. The x cubed change signs. Odd. 13 inverse. This is what we did yesterday. You swap your input and your output, and we'll just forget about the of x part here. So we'll swap f and x. Now we got to solve for f. The whole side is divided by 2, so I'll multiply by 2 first. Subtract 6. Divide that whole thing by -3, and I'm going to write this off to the left side here. That's basically it. Put the -1 on to mean inverse, slap that x back on. Now, you might separate that and say -2/3 x plus 2 if you actually do the division there. But technically, this is good enough. 14, forget about the of x part, swap f and g, or excuse me, g and x. Minus that 20. Divide by 5. Put the -1 on to be an inverse, put the of x part back on. And 15, 15 is the easiest one here. Swap y and x, there's no function notation. Multiply by 2. Put the -1 on. And there you go. I think, yeah, that's it.